Hey everyone. Thank you for joining us for the next session of our Spotlight on GitHub Advanced Security series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters and moderators to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you all so much for joining.
Thanks so much, Anna. Welcome back, everyone, to another episode of the GitHub Advanced Security series. With me today is an awesome partner in the space. As you know, we love to make these sessions free, ungated content to the community to get you up to speed with the latest and greatest of what's happening in the application security space. So before we get started, if you are tuning in for the first time or if you are tuning in on demand, I encourage you to subscribe so that you can follow along. You can also chat with us while we're live. And then most importantly, if you want to continue the conversation and nerd out with us after, feel free to make sure that you opt in to the GitHub notifications so that we can ping you or provide for you whatever else you need after this session. So before we get started, today's session is about shifting offensive security left, rethinking DevSecOps in the age of AI. So what I'm going to do first is hand it over to the Expo team to actually let them introduce themselves. Then we'll hand it back over to me. I'll give a brief introduction, high-level overview, and then we'll pass it back to them.
Perfect. Thank you very much, Lupita. So maybe I can introduce myself first. My name's Matthew. I'm a field engineer or field specialist here at Expo. And with me, I have Alvaro as well.
Yeah, so hi everyone. I'm a security researcher at Expo and happy to be here.
Awesome. Thank you, Matthew. Thank you, Alvaro. So for those of you who are new to this session, we always kind of set the context of the expectation that you kind of already know what GitHub Advanced Security is. And really the reason why I like to put these on is to provide insight on why it's so important to collaborate, right? Because there's simply no room for compromise in this space. So I'm going to start with my background, what I've done, where I come from, just to give you a little bit of insight on my experience. That way you get a sense for kind of where my opinions are forming from, and then why it's so important to work together as a team. So I'm Lupita. I'm an application security executive here at GitHub. I've been with the company for about 3 years, but prior to that, I was at Veracode for 7 years. And before that, I was actually a full stack developer building the static engine for IBM AppScan. And I like to give that context because I've kind of followed the trends of technology and gone through and seen what works best for the developer experience, right? We want to give them what they need to succeed so that they stay within alignment, so that they stay in flow state, and they stay happy. But we know that with the age of AI, everything is getting more complex. It's becoming more insecure. So what we're going to do today is talk a little bit about what we're seeing with the gap in DevSecOps and how we're bringing autonomous offensive security that scales. Matthew here and Alvaro are actually going to show the integration between GAS, Copilot, and Expo. And then we're going to talk about how continuous proven driven offensive security works inside the CI/CD as a whole. So let's start with the DevSecOps gap, right? Most of you know that when it comes to applications, the traditional approach has always been a pen test, right? Because a security auditor is asking, or you need to meet it for compliance. And that usually happens yearly, right? You have some firm come around, do a scope, figure out what needs to be tested. They usually take like a week, sometimes a month, and it's really expensive. And you oftentimes just focus on the most critical applications and don't necessarily get to your whole portfolio because it's just not something that's scalable. It's really hard sometimes to even get on the books for pen testers. And so what we're seeing today is that with the move of AI or the adoption of AI, people are moving really fast, whether that's a ethical hacker or black hat hacker, or even just developers as they're increasingly creating more code. So what we've seen is the whole shift left movement, right? At GitHub, we've focused on the developer experience, helping bridge that gap between developers and security folks so that they can work through and fix some of the flaws and vulnerabilities earlier on in the process, the low-hanging fruit, if you will, the things that aren't related to like business logic or more complex types of attacks. And with that comes some of the automated solutions. So for those of you who aren't familiar with what those are, I'll kind of give a brief overview, but if you want to learn more, you can always go to another Reactor series session where we dive deep. But the main thing that comes with application security within GitHub is 3 components. The first one is what is known as static analysis, SAST for short. We actually have an engine called CodeQL that does that assessment. This one is the kind of primary way to give you insight on what are the potential risks within your first party code that you are writing. Now we know that there's code being written by AI, but most of those AI suggestions are already coming out secured by default. They have their own scanners running, so you don't really have to think about that. But for the code that you're running or writing yourself, you're going to want to do an assessment. It's kind of like a spell check, right? Except for from a security standpoint, telling you where the gaps are. I always like to give a little bit of insight on like what's really happening behind the scenes there, because it's going to give some context on why this matters to have pen testing in the first place. Static analysis is an NP complete problem, mathematically speaking. That means there's no right answer. It's not 1 + 1 = 2. The complexity of it is just so hard to solve that I think AI is getting closer, but we're not quite there. You might hear about static analysis tools that are using AI to identify flaws, but there's still some room for growth. So that being said, because of the complexities, what I always like to tell my customers is that there should be an expectation that what you're receiving from a static analysis engine is only providing you potential risk. Hence why they are identifying CWEs. CWE stands for Common Weakness Enumeration. It is telling you there might be a risk here. It's not telling you CVEs. CVEs are common vulnerabilities, right? And so what we're focusing in on is, in this session, how do we remove all that noise and focus on the ones that actually matter based on attacks that are proving that code in your actual repo might have bigger impact, right? Because you're going to have false positives, you're going to have false negatives. There's no right answer to static analysis. So that's sort of the first gap that we see with DevSecOps. With SEA, Dependabot, third-party libraries, as we know, we look at those and tell you what are vulnerabilities that are found in them. Well, these vulnerabilities, I always say, once they're reported, they can be exploited, but your data is only as good as what's in the National Vulnerability Database. And or in our case, we have our own database, right? That we have contributors collaborating with us to provide that information. But now that information isn't always the latest and greatest, right? We have new vulnerabilities being identified every single day. And are they getting updated? We don't know. So again, there's a gap there. The last one is secret scanning. Well, you can look for all the secrets in the world. There's still like new patterns coming out, new tokens, new vendors. Keeping up with that list does require some work. So essentially there's no silver bullet, right? So while we have the signals, while we have the information, we're still missing the exploitability based on what should we prioritize? What's in production? How do we know? And pen testers, well, they don't have the time to like dig through everything. They're usually relying on you having already gone through static, SEA, dynamics, so that they can focus on hard to find business logic type of attacks. But even then, like their list of, different applications they have to go through is expansive because there's a limited amount of resources in the space. And so doing that on every release is just not feasible. Hence why you see some folks just doing it maybe yearly, if they're lucky, quarterly. And so I think the biggest thing here is that what we see is most folks are still pushing code to production that have security debt, right? Here's a quick slide to just give you some insight on like what percentage of applications actually have flaws while in production. We're seeing about 80% of them. 56% have high severity flaws, and that was produced by the 2025 State of Software Security Report, which is wild. But then we also look at the types of typical flaws, right? That being said, I think how we can change that, we know that we have AI to create more code, but the bad guys also have AI to create more type of attacks, right? So the nation state and criminal actors are now adopting LLMs for reconnaissance, coding, exploitation support. They're creating more payload scripts, accelerating their targets. So the bottom line is that offense moves in minutes, signal quality and automation has to keep up with that tempo. It's the Swiss cheese problem. So what does that mean? Single findings rarely sink ships, right? Chain weaknesses do. So while we have SAST, while we have SEA, there may be configuration quirks, business logic in combination with that could produce more type of exploit paths. And so teams need help turning all of that noise into prioritization, validation, and making sure they know what attack paths are truly going to have an impact. So that being said, we're going to stop here and just check in. I know I provided a ton of context, probably didn't even let you blink, but I think that was important just to kind of set the stage. I always say it's so important to have expectations leveled so that when we go through these different concepts, you get why things are the way they are. So with that, let's go ahead and see if you all paid attention and do a quick poll. Where does most of our AppSec noise come from today? Would you say it's SAST, SEA, from secret detection, from DAST, or all of the above? We can't actually see these results, so we'll have to follow up after. But just think about that. We're trying to get a sense for what everyone's experience is. Matt, Alvaro, any thoughts from your end on what you believe would be the noisiest?
Alvaro, go first, and then I can maybe add my bit.
Yeah, so that's a good question. For me, I think like there's different things in terms of what is noise is. So SCA, for example, in this case, dependable, is very accurate. Like you have this library is running this version is running, this contains this vulnerability that has been reported and it's very well known and it's even been fixed. But does this vulnerability get exercised in your code? That's a different question. So you get a lot of dependable areas that you better update as soon as possible and update these libraries. But how is that a priority, or do they get exercised? That your application is susceptible to these vulnerabilities or not? So I guess for me, I think SCA would be in this case the source of more noise understood in this way.
What about you, Matthew?
At least from personal experience, I've seen more on the side of like where the noise comes from can be things like DAST, like traditional DAST kind of solutions, at least in my personal experience. So like I've seen a lot of like, I don't know, outputs of reports from like maybe classic DAST tools where they produce like a lot of false positives and things like that. And if you ship that straight to the developers to go and fix them, it becomes a big pain point. But all of these can have their various issues with this. But yeah, hopefully we'll kind of show you the evolution of this as well.
Right. And I'm so glad you brought that up, because a lot of folks ask me, does GitHub do dynamic analysis? Do we provide pen testing? Some point players in the space that offer application security do so. But to your point, in the more traditional clunky ways that haven't always been beneficial. And so hence the partnership and the collaboration. I think the desired state for DevSecOps and offensive security unified is that we reduce the number of flaws that we go through and prioritize and fix the ones that we can actually validate. To your point, Alvaro, is this in our attack path? We don't want to spend our time on dead code. There's things that simply take developers away from wanting to adopt solutions. And so the more seamless, integrated experience they can have, the more likely they are to adopt. How often do folks today run pen tests? And I'm asking this because I said there's no silver bullet, but you're gonna hear about Expo's magic approach, which is pretty exciting. That kind of bridges the gap between pen testing, dynamic analysis, and then helps you kind of tie it back into that developer experience. So let's see where everyone's at. Would you say every release, quarterly, annually, only for compliance, rarely or never? And then while the audience does sort of that assessment on their own, personally, I've seen most folks just do it annually to check the box. More bigger enterprises will do quarterly for like high priority applications, but it's expensive. And then Matthew, Alvaro, what's been your experience?
Yeah, I think that unfortunately, that's the reality these days. It's either annually or maybe like half a year. But I think that all of them agree in the value of pen tests, right? Is having a human reviewing your applications, looking for corner cases that maybe static analysis or dynamic analysis tools may miss, is very valuable. It's just that doesn't really scale very well. As you said, it's very costly. It takes time for preparation, takes time for execution. It takes the resources. Actually, the good pen testers is a limited resource. It's not easy to find, right? So unfortunately, that makes it very hard to actually run it on every release. I think everyone would love to do that, but it's just not possible.
Yeah, and to add to that as well, I think pretty much Alvaro mentioned it perfectly. I think what I see is personally quite annually is maybe every twice a year is what I see in this. Or some of my customers previously have done it for compliance. Like they come knocking on the door, or suddenly we have to spend some money to get a pen test done as well.
Right. And I think one of the bigger issues I saw is as it became more of a necessity, but harder service to receive, sellers like myself would just quickly scope. We'd say, it's going to take 3 days or 5 days without knowing the reality of what really needed to be assessed. And so I think that can sometimes put you in a weird state of false sense of security. So that being said, let's introduce Expo, the autonomous pen testers that scale. So I'll hand it over to y'all to give us your show.
Perfect. Thank you so much, Lupita. So yeah, we've talked a little bit about the DAS space. I want to kind of introduce Expo, which is our agentic platform for autonomous pen testing, that we actually leverage AI models to find security vulnerabilities at scale. There's lots of words there, but the kind of core thing around that we want to focus on is leveraging the kind of more on that pen testing side of things, instead of relying on traditional DAS tools that are very highly scripted and things like this, that maybe test this one API endpoint for these 20 vulnerabilities. And then once it's tried it and it's not worked, let's go to the next one. We want to actually leverage AI to actually make it so that we have an agentic agent to help us pen test those specific applications. So not just test that one thing, but maybe step by step chain a bunch of specific things together to find security vulnerabilities inside of applications as well. So you can leverage Expo to kind of point to a running application that you have in your environment. You can set it up so that then, of course, we can actually do this. We mentioned the beauty would be every release, right, that we're doing these analysis. But as we mentioned, security people, getting them to review every release, and you're releasing, I don't know, let's say maybe once every week, maybe every 2 weeks. That's a lot of pen tests, and we want to make sure that we can fully make it so that we can use our specialized AI agents to actually find, discover, exploit, and validate these security vulnerabilities. So all these steps together really make it extremely powerful. Alvaro will talk about that a little bit more in detail in a moment. But we really want to make it so that we can shift that pen testing to an earlier stage, so we can do it more frequently as well. So that's really, really important for us as well. And also coverage, right? Like, one of the things that we didn't ask, which was, you're doing pen tests, but are you doing it on every application? From my experience, it's always been like, hey, we have a portfolio of 500 applications and we need to pen test, like, there's maybe 20 that are critical. We must test these things. And we only test those. We want to make sure that you can have full coverage across those portfolio of applications and environments and things like that, and find those vulnerabilities as well. Some of you may have heard of Expo in the past year or so, because I think one of the really awesome things that we were able to achieve was the beginning, or like in the middle of this year, we were able to actually find and discover thousands of real vulnerabilities in the HackerOne leaderboard for bug bounty programs. I think this is an incredible feat that we're able to find these real vulnerabilities, report it to all of these different large, mostly Fortune 500 companies across the globe, to actually discover real vulnerabilities in these. And these were done from like a black box, no source code, no additional information apart from what is provided inside of their bug bounty programs as well. So, and I'm going to pass it over to Alvaro to talk more about how Expo works.
Yeah, thank you, Matthew. So basically, let me give you like a very high overview of how Expo works, like from 10,000 feet. So it's very easy to get started with Expo. You can just set up an assessment by providing the URL of your live application, either in staging, test, or maybe production, and then configure what is going to be like the credentials that you want to use with this assessment. You may use one or several credentials in order to test things like IDORs, business logic flows, etc. And then that's mostly it. You just run the pre-flight, which is going to make sure that the application is reachable, that you can actually log in into the application, keep the session authenticated, and then do a little crawling of the application, a small mapping of the application to see what resources are being loaded, what other maybe subdomains or different domains are accessed, so you can narrow down the scope to exactly what you want to test. And that is very important, because Expo will keep in a scope of what your boundaries are defined in the setup. And then with that, you can just start the assessment as is. And basically, the way it works, and we will see that in the next slide, which is a little bit more detailed, but we have this coordinator agent. And you can think of it as a manager of a pen tester team, right? And it's going to start like saying, okay, you two guys are going to look for mapping the application, discovering endpoints, discovering if there is, I don't know, a GraphQL endpoint, what operations are exposed in this endpoint, if there is an API, etc. Then you other two are going to start like checking how authentication works, for example. Do you need to go through a two-factor authentication, multi-factor authentication, email, one-time passwords? All of that is handled by the agents on their own. And then once that we have this information collected, there's another agent or pen tester agent that will basically, you can think about it like a really senior and seasoned like pen tester, and we'll decide, okay, now we need to focus on these endpoints because these ones are reflecting information or data from the request. These other ones looks like they may be potentially vulnerable to these other categories, and then it start organizing its team. But it's not a team of 5 or 6, I don't know, pen testers. It's an army of pen testers that are going to run in parallel, like hundreds of them, to try and get to find vulnerabilities in your applications. So this is a step number 3, where these agentic pen testers are exploring your application and looking for vulnerabilities. But we all know that, LLMs, AI in general, is hallucination prone, and it's gonna hallucinate, especially when you tell it try very hard in finding a vulnerability of this class in this endpoint, then it's going to try that hard that sometimes it even just creates something and it believes it on its own. Like, I really think that this is vulnerable, but it is not, right? In some cases. And that's why we have to develop these validators, which is a concept that we developed, which is basically the idea of we can't fully trust LLMs. So LLMs are really good because they are trained with a huge training data set that knows everything about most of the vulnerability categories, exploitation techniques, bypass techniques, etc. But then they are still like kind of cheating prone. And then we need to, okay, show me your homework and we will validate that to see if it's real or not. And that's what we do with validators, which are mostly deterministic. They don't use AI, and we use that to validate if these vulnerabilities are real or not. Next slide, please. Yeah, so this is more or less, again, the architecture of what I just told. We have this coordinator, which is going to spawn different agents. There's going to be a number of discovery agents running at the beginning, like mapping and exploring and crawling the application, discovering how it works. And then they are collecting and debriefing all this information. We will have these authentication agents that will try to get the session authenticated and then share that with the rest of the Pentester agents for them to use. Sometimes they want to run authenticated. Sometimes they want to try a vulnerability without any authentication to escalate, for example, the impact. So this is in the responsibility of these auth agents. And then as it needs to focus on some specific vulnerabilities, we have a number of specialized pen testers. And we have agents that are specialized in getting remote code execution. That's we don't normally talk about CWEs in the sense of, okay, we cover like CWE, I don't know, for 78, which I think is command injection, or the one for unsafe deserialization. We care more about primitives, exploitation primitives like remote code execution. We don't really care about if it's going to be through an unsafe deserialization, command injection, argument injection, code injection, eval. So what we care is the agent able of running code in your server, and we know how to validate that. So that's the way we kind of group and bundle these agents. And then all of them share these attack machines, which are provided with a set of tools like the standard Unix tools, but also hacking tools and our own headless browser, which is basically the way that these solvers or agents browse the application. It's kind of LLM-friendly browser, but it's based on Chrome, so it's something as kind of standard. And then we talked already about the exploit validations that, as you can see, are not connected to LLMs. This is kind of deterministic code that will make sure that vulnerabilities reported are real, and these are connected by these validator clients. So all the traffic goes through this network intercept proxy, which is basically the way we have to enforce all these boundaries and the scope that we talked about before, and also the way that we have to log every single request and response. And not just that, we also log every single agent thought, agent command, agent response. So we log everything, and everything is available for the security teams to actually analyze when we find a vulnerability, like we will see in a few minutes, but also to see what kind of exploration the agents did. You have everything logged into the extreme detail. So yeah, let's move to the next slide.
Perfect. So this talk is more focused at like how do we connect all these pieces together, right? We talked about like the GitHub Advanced Security using QL and Dependable, etc., and a bit of Copilot in here. How do we integrate these all together to really kind of showcase like an end-to-end experience of like what it would be like for having a hacker on your team as an agent to then maybe be supplemented with some of these information from GitHub, for example. So what this looks like as like a core concept is that you might have security findings that are been discovered by CodeQL or by other SAST tools, and you kind of want to bring this as part of a bit of context to Expo to see whether or not, like, hey, is it actually exploitable? Like, if I provide a dependable alert that says, hey, I'm vulnerable to CVE XYZ, am I actually exploitable using this specific thing? Or would it be the same for CodeQL? Hey, we have a in our case that we will be showing data today, a server-side request forgery issue. Can we actually exploit this? And is it a valid exploitable vulnerability? And of course, we want to spin up those agents and actually validate that this is actually exploitable, and then of course create a proof of concept as a result for us. But then we'll kind of showcase what the workflow is to actually get this resolved and work with GitHub to like fix this vulnerabilities as well. So maybe as part of the first demo, let's see what this looks like from like GitHub advanced security into Expo to give it that context. So I created just a small video to begin with around like just showing like the specific GitHub repository I have. So if I press play on this as well, because of course we all want to make sure that the demo gods are very friendly to us. But we have a specific repository here inside of GitHub that, of course, we have a few different vulnerabilities and alerts that have been discovered by CodeQL and some of also by Dependabot. So I kind of wanted to show this as kind of like a preemptive, like, hey, this is like kind of the context that we want to provide this. I wrote this script as just an example of how you get that data, but you could also ingest this automatically. I just wanted to add this as like how you would get that data from GitHub. Now, we can actually provide this data as part of an Expo setup. So I'm going to go through here and actually set up a new application where I can set up, for example, that I want to focus on scanning the whole application, or in our case, maybe want to look for specific things that we want to actually identify as well. For this setup, I'm actually going to just create it using a comprehensive test. But as part of this setup, you can provide your production or like staging environments. Highly recommend staging versus production environments, because normally you're actually deploying like maybe your pull requests. Maybe you're deploying those to a staging environment. You can enter these URLs in here, for example, to your staging environments, set up credentials, authentication. Alvaro kind of already mentioned about the authentication piece. But the other thing that you can do is actually provide specific artifacts to Expo. One of them, of course, being source code. So instead of just trying to guess and crawl the website for like understanding how it works, you can also supplement it with source code. Hey, I see there's 15 API endpoints over here. I know where to go and look for those things. That kind of data. You can also do this with SAST artifacts as well. So I'm going to upload just a couple of these things. I'm doing it manually just so it's like easier to show, but you can imagine this actually being automatically ingested into my application as well. And you can connect it to like a GitHub repository as well to get access to that source code as well. What we actually do, I think Alvaro kind of already mentioned about this around like the pre-flight. So we want to make sure, of course, that we are actually making sure that the environment is up. We've provided all of the bits and pieces that we need, like CodeQL results and things like this. And then we can make sure everything's working and ready to start assessing as well. So I'll move over. So that's kind of like the setup piece. So I'm going to pass it over to Alvaro to talk more about the actual exploitation of this as well.
Yeah, thank you, Matthew. So the idea here is that we are going to try to get into the mind of our Pentester, in this case, into Expo mind, and see how did it try to validate these CodeQL alerts and get to convert a bunch, a number of findings into exploitable validated findings, right? So in order to do that, we are going to just run these agents that I mentioned before with the different goals, right? So first goal is going to be ruling out false positives. Having worked in the SAST space for a long time, I don't like to mix things, but false positives are things that are really false positives that they don't make any sense. In some of the cases are noisy results. Maybe, static analysis tools have some limitations in terms of they have to emulate how code executes because it's not running your code. So it needs to like model how methods behave, how they pass untrusted data from one argument to the return value, etc. Sometimes these models are not perfect and they can connect things in an incorrect way, which may enable like not realistic data flows, but there is a small part of truth in there. There is a missing validation, missing sanitization. There is a sync that is not properly sanitized. So that's why I don't really like to put like everything like as false positive, but maybe like noisy results. So we are trying to roll out all of these noisy results, and then use XBOW to verify what's really exploitable, what should be prioritized in terms of remediation and fixing. Not just that, because the way that XBOW works as a real human pen tester, it's not going to just focus on the code QL alert in this case, in the data flow from the source of untrusted data to the sink. So it's going to also see the context of this vulnerability of this data flow, and it may find potential branches of this data flow that makes something that could be not exploited into something that can be exploited, and that maybe the static analysis tool missed. And this is exactly the case that we are going to show today. So this is one, actually the findings. So after running XBOW in the results in the SARI file that Matthew shared, if you remember, I think it was like maybe 80 code QL alerts. Most of them were like very low informational or medium severity. There were a few of them that were critical, but do you have to stop your pipeline, like don't release to production or to staging just because you have those alerts? That's what we are trying to answer today. And the answer is that depends, right? So if you can prove that that's exploitable, then you have to actually fix it as soon as possible, right? And this is the case here with one of these 80 alerts, which was a server-side request forgery in Apache Druid. And here's how XBOW presents the summary of the finding. We have the summary of how it works, what are the different parts involved. Like there is this path, and then this servlet, this Java servlet that is handling this path connected to this endpoint, and then it provides the exploit and all the detailed steps that you need to reproduce in order to reproduce the vulnerability. So this is very valuable to a developer. It's not the same thing as presenting this is a SAST tool with this data flow from source to sink that you have to navigate and make sense of, to, okay, these are the steps that you need to actually reproduce the vulnerability, and it's fully verified, right? So let's dig deeper into this pentester mind. And this is how the trace starts, right? So we saw before that we log everything, like every thought of the LLMs, the responses, the commands that they execute, the requests that they send, the responses that we get from the application, everything gets logged. And this is really very valuable for the security teams, not just to understand the vulnerability, but how XBOW found the vulnerability, which matters in many cases in order to train your teams, etc. So at the beginning, it's just basically just taking the information provided with it's basically just the SARI file with the specific data flow from the source of untrusted data to the sink. If we can move to the next one, please. And what it's going to try to do is make sense out of that information, right? Exactly same thing as a human would do. Like, okay, this is this source of data that introduces the taint because it's reading in this case, is the get request URI. So that means it's reading everything after the domain and the port. So everything, the path of the request of the URL. So that's something that an attacker could control, may control at least some parts. And then that's going to get propagated throughout the application through these methods here, like these getty utils concatenate for rewrite, until it reaches a method that sends a new request. So, okay, after like 3 or 4 iterations, the LLM said, okay, now I understand the flow better. I have a whole understanding of the picture here. So I'm gonna try to continue the exploration. So what's the next thing that a human would do? Okay, I know that the untrusted data, the tainted data, as in terminology of static analysis tools, comes from this request.get request URI. But okay, what request are we talking about? So there is a work here, a job of mapping this method call within a specific part of your code base to how I can reach and hit that specific endpoint in a live application. And that's something that sometimes is kind of easy depending on the frameworks. sometimes it's a nightmare, right? So you start pulling the thread and say, okay, this method is called by this other method, which gets called by this other method, which is handled by, and then it's a nightmare for the code reviewers and Pentesters to understand where the data is coming from and how to hit it. So this is something that Expo did. In this case, it was a servlet that was mapped. I don't know the details, maybe through an annotation or maybe through the web XML file in Java applications, to these two paths, the Druid version 2 and the Druid version 1 lookups paths. So now it has a way of actually exercising the vulnerable data flow, right? And this is the name of the servlet. And try to remember this name, this async query forwarding servlet, because this will be relevant a few slides later, right? So next slide, Matthew, please. So the first thing that it's gonna do is like, okay, first thing that it did is, I think it just sent a couple of requests to see, to test the waters, like to see if it gets a 200 or a 500 exception or whatever. And then it stops and said, okay, let me think about it. So now that I have a full understanding of the code, now I know that whatever I put in the path of my request is gonna get concatenated and it's gonna craft this other URL. In this case, some broker host, which is not under the attacker control, then the /root version 2, which is not under the attacker control, and then some user input that can be controlled by the user. So at this point, the agents thinks, okay, this may not be exploitable because actually, can you move to the next one? I think it tries a very well-known technique, which is using the @ symbol. So in order to try to make anything that comes before the @ as the authority part of the URL, so that is the user and the credential, the password, and then everything after the @ symbol will be the final server, the real server that is going to be hit, and then the path, right? So it's going to try to do that, but in this case, because the prefix, it's prepended to this before this @ symbol contains these forward slashes, then, and these are not URL encoded, these are going to be considered as the full path, and then this technique is not going to work. So next slide, please. At this point, it's going to say, okay, this is not exploitable. First of all, the broker servers are not configured, so I'm always getting a 500. But on top of that, there is no way I can control that part of the URL that I need in order to exploit the vulnerability. And this is something that I referred with noisy results. In this case, we have like tainted data, which is user control data in the form of a request path. But to fully understand how this data gets modified, propagated, how it gets prepended with other strings or appended some other values, in order to understand if when it hits the sink, it's exploitable or not. So what Expo did in the next slide, in the next iteration, is, okay, I'm gonna see if this same jetty utils concatenate forward write method is used by any other servlet, and then it found another one. Remember, the other one was async query forwarding servlet. This one is async management forwarding servlet. And this one is mapped to these other 3 endpoints. And it turns out that if I, next slide, if I use this very same technique of appending or using this @ symbol, the way that this servlet is rewriting and crafting the new URL makes it exploitable. So now what it's doing is, if, for example, if I hit the /coordinator / whatever, then it's going to replace, the /proxy /coordinator is going to just make a request to coordinator and then append the path of the original request. So because we can start the path with the @ symbol, then we can actually change the semantic of this URL and point it to the internal server and then hit the whatever server we want and get the response out of it. Next slide, please. Yeah, so this is a good example of how Expo can think like a real human pen tester. Is gonna map the application, is gonna understand the static analysis finding, is gonna try to make sense out of the data flow, is gonna see if there is anything preventing exploitation, and then it's also gonna look for variants around. So over to you, Matthew.
Awesome, thank you. So we talked about like, oh, we've actually found this new like exploitable path, like it's slightly different to what the results in the SAST tool found, but it found that variant. So now the next phase, of course, is that we verifying that it is actually exploitable. And how do we get this back to the developers, right, as quickly as possible? So one of this, of course, and some of you that the eagle died among you may have seen in one of our previous screenshots here, was that actually you do have as a concept, like you have this capability of actually, sorry, I read there, you can actually request an auto fix using and leveraging GitHub and GitHub Copilot. So in this case, for example, so it's verified the alert, and it has a proof of concept, as you can see in the rest of the issue, of how to exploit this. What can we do? We can actually create a GitHub issue. And if any of you are familiar with GitHub issues, which I'm hopefully everybody that's joining us today and watching in the future, all have used GitHub issues in their time as a developer or reporting bugs. We want to create a issue for the specific developers. So, hey, we're going to add this to your backlog of, hey, we found this vulnerability in this specific application, a little bit of context. But the most important part is we've also mapped back the, hey, this was actually found in this specific servlet. So I won't zoom in, but you can kind of see here that it's pointing towards that async manager that Alvaro mentioned earlier as well. So this allows us to create these issues, but of course, like all of us hate backlog. All of us wish our issues were zero as developers. So what we want to do now is take that alert, that issue that we've just created from those results in Expo. How do we actually make it so that it fixes or helps us fix this vulnerability? So we're actually leveraging GitHub Copilot's coding agent, which hopefully, if everybody here is familiar with it, please go and start using it today. It's a fantastic tool. But what it allows you to do is take this issue in the context that's provided by Expo and assign it to Copilot to make sure that it can go ahead and fix this. And this really helps with that, like actively fixing and wanting to fix those security vulnerabilities. And of course, we can leverage Expo to revalidate these results. So I'm going to just skip forward to the next demo, which is around how can we actually get it to actually go ahead and fix these issues as well. So you can see here, we have the issue. And some of you, again, eagle eye among you with this one, is you would have seen us automatically assign the GitHub Copilot coding agent. So now what happens is that automatically gets picked up by Copilot. We've told it, hey, you need to go and fix this vulnerability. Here's all our context. And what will happen is it will go now and start thinking about, how do I go ahead and fix this? I know all of the different variables and I know the code snippets that are actually vulnerable to these security vulnerabilities. How do I go ahead and like fix this? And of course, some of you, this was something that I learned a few months ago around like, hey, you can actually look at see how GitHub Copilot coding agent is actually fixing and going through the process of thinking and fixing this security vulnerability. And because of this context that we've provided as part of Expo, it's gone ahead and like, okay, after about 12 minutes, I think I have on the clock here, it's actually updated the pull request ready for a developer to review. So of course, like you come back to here, this pull request, and you will actually see like, hey, we've actually done some small changes to help fix this security vulnerability. The other thing that's really amazing about the agent as well is that because we've supplied it with a bunch of test cases of this is how it's exploitable, here's the specific payloads, what it will do is also write the tests for you. Like that's a fantastic feature. So you stop having these kinds of regressions as well. And then I'll pass it back to Alvaro to talk about like kind of the end-to-end, like around like revalidating this as well.
Yeah, thank you, Matthew. So this is a very short part because it's basically just you have this verify fixed in the Expo UI. And when you click it, it will start a new assessment, which is going to be a targeted validation assessment. It's not going to just kind of reproduce the same payload, like, for example, the same, very same exact steps as it used in the past. But actually, it's going to try to, okay, this was the vulnerability, the root cause of the vulnerability. I'm going to try to see how it was mitigated. I'm going to verify it was mitigated and try to bypass any mitigation. And then if I can bypass that mitigation, then I'm going to claim that it's fixed. And then I'm going to report that back to GitHub in order to let the users know that it's been fixed. So yeah, as I said, it's gonna start like this is gonna happen automatically behind the scenes. But again, for transparency, as you can see, what is going on, it's gonna start like if you were like targeting the staging server, it's gonna point to the staging server, and it's gonna you don't have to configure anything because it's gonna reuse the credentials, it's gonna reuse the source code documentation findings that you provided in the first and original test, and then just reuse them in order to verify if the vulnerability was fixed or not.
Perfect. So kind of to recap, like the full end-to-end demo here as well, is around like we've looked at like gathering extra like context for Expo to actually go and see, and they can verify the security flaws that might be generated inside of these code bases. Of course, there's a lot of like code that's being produced today. I can't remember the stats, but it's like an insane amount of code is being generated using LLMs. And of course, like humans as well, everybody makes mistakes, including LLMs. So we want to make sure that like, hey, if you do detect security vulnerabilities, we want to make sure that we can detect them and prioritize them to say like, okay, this is a valid security issue, or hey, this is not exploitable because of XYZ, and provide those reasonings as well. And if it does actually prove that it is actually a vulnerable application, we want it to, in our case, we just click this button, but in the future, it might be like automatically creating that auto fix for the users as well, and utilizing something like Copilot coding agent to actually fix these as well, and then reiterate on that as well. So once the pull request is finished, of course, if you have a deployment set up so your staging automatically gets updated with your new with a new pull request or something like this, then we can retest and then of course close the loop and hopefully, for example, close out the alert being detected as well, which is fantastic. Alvaro, back to you.
Yeah, so now I think we are running out of time, but the last part we want to share what we think is the future for these autonomous agents and how they are going to perfectly fit in the CI/CD pipeline because of how they can quickly scale and how they basically can run what humans would take days or weeks into a few hours. And that's something that fits the CI/CD pipeline. So I think we have another poll for you folks, which is something that Matthew already mentioned. What's the percentage of code that is AI generated today? And while you are answering that, I think we can comment on that. I don't know. I started using, the Copilot coding agent in the CLI Code Cloud, and it's really helpful, right? So also a little bit scary, right? Because all these tools have been trained with the open source software, and we know that open source software is software, and therefore it contains vulnerabilities. So it's been trained with vulnerabilities, and that's why it's great. We have these tools for helping us developing code, but also we need to be extra cautious about what code is being written.
I love the comment from Writing Panda. All of it. I don't even write code anymore. Code writing.
Yeah, like I personally, I'm not a UX developer or I don't do any like front end stuff, but I have a few projects that have front ends, and I just let Copilot or anything else like AI generate me that code because honestly, I don't want to deal with this anymore. Making things pretty. So cool. We can move on to the next bit, and then hopefully we can maybe see the stats in a bit as well. So yeah, just to kind of wrap up, and hopefully we've got a few bits like towards the end for questions. So as we already mentioned, like large amounts of code are being generated by AI. Of course, it's the same as humans. We're all can accidentally introduce a new vulnerability. We want to make sure that we can leverage AI to actually scale out that like testing of whether or not it is an exploitable, and make sure that we can verify those fixes as well. Or, for example, validate that those specific exploits are working as well. So we really want to make sure that we can provide not just like a bombardment of results, but also validate it. So when they get passed to developers or by security engineers, whoever it might be, it is a valid security vulnerability that needs to be fixed as well. Of course, we mentioned at the beginning around like how often do you do pen tests? How often do you do you pen test your code? And it's we didn't see the stats, but it's probably something like annually, which is a no-brainer. But what we want to do is leverage something like Expo to actually, during that CI/CD process, you can actually run a lightweight Expo instance where you're actually validating security vulnerabilities that might be detected as part of that process as well. This would be amazing to see, like, okay, because nobody's got a pen tester that comes in every pull request and verifies whether or not like those vulnerabilities that have been detected by those SAST tools or whatever are actually like exploitable. So it's a really cool thing. And of course, retest it. So if a developer or another agent goes, oh, I saw that vulnerability that you introduced over there, let me go and like fix this now. So really helps with a lot of this as well. And of course, what does success look like? Of course, the success would be like there's no exploits ever, and we can all live in utopia as well. But we want to make sure that like towards that state, which is like nirvana for security people, we want to make it easier to make it so that we can actually look at the like mean time to validate those security vulnerabilities in minutes versus like weeks, months, hopefully not years, but let's go with months. And we want to fix those things as quickly as possible and also reduce that high risk. Because if, for example, you have a server-side request forgery, it's going to be high risk to your like organization. We want to make sure that those are discovered and then also triaged by our agents as well to make sure that they are being are not present in the code as well. And of course, as I mentioned, providing that context back to developers. One of the things I always heard from developers working with like pen testers and things like this, so I used to be a pen tester, is that, oh, they maybe get annoyed or get scared when they became knocking on the doors and things. We don't want that. We want them to really see like a valid proof of concept that works and they know how to go and like fix it and they get that real world example as well. So we've only got a few minutes left, but I wanted to add just a quick last poll as well. Where would validated exploitability have the biggest impact? Because I think this is more focusing on like what are the biggest pieces that would be really powerful to see the biggest impact of like validating exploitability as well. So we only have a few minutes, so I will move on to the next one just to kind of like wrap up and we can answer some of the questions that we might have in chat as well. So want to learn more? Of course, you can spin up your own pilot. You can also go and enable GitHub Advanced Security today as well. So that's something that you can definitely like do as well. But also, if you want to get in contact and like chat with us, Expo, you can scan the QR code that we have on this slide, or if you're a security tester and you're very skeptical about QR codes, which I completely understand, there will also be links in the chat, I'm sure, being provided as well. So you can click those. Although, yeah. Okay, awesome. Maybe we can leave the last couple of minutes for any questions. We only got a few minutes, so we'll see if there's any interesting questions in the chat. I can't see the chat, so maybe you'll have to rely on somebody else. To see those.
I think most questions have kind of been followed up by the team at Expo, but one of the ones that kind of stood out to me is how do professional pen testers feel about Expo? And I really loved the answer that Dan gave. So I don't know if you want to shed more light on that because I think it's accurate to a T.
Oh, do you want me to go, Alvaro? Because how I see this personally is that this works alongside a pen tester. Like that's how like we see it at Expo as well, is that we use this, like I can imagine this was the same with developers, right? Back in like 2021 when they saw Copilot, they went, oh no, that's my job gone. And that was what, 4 years ago? So we see this as more of a like
the way that we see it's that it's a multiplier that comes to help the pen testers. So imagine like instead of having to review pull requests and see how they could affect or not this new change in the application, you can focus on like doing a full pen test of the most critical application where your expertise and your knowledge of the stack tech stack of that particular application is crucial, and then leave Expo to run and verify these pull requests to run like a periodic assessment instead of you having to do that every single week. So I think if you see it that way, like, oh, I'm gonna be able to focus on what matters the most for me. We were mentioning Pentesters as a scarce resource. There are not so many, even if you hire them or you have in your own company. If you can get them to focus in what matters to them, they will do a much better job, and then you can delegate the rest to Expo.
Do we have time for one more question? I don't know if Lupita or anybody else saw another interesting question in the chat we can answer quickly before we wrap up.
I think we are good. Most questions have been answered, and we've provided ample ways to connect with us afterwards. Like I said, make sure you subscribe and also opt in to get notifications afterwards. As you may know, GitHub Universe is next week, so stay tuned. The following weeks after, we'll have way more content on everything that was announced. And if you are subscribed, who knows, you might get a Octo card to go into our swag shop to get some goodies. So stay tuned, follow along. And if there's anything else you need with Expo, you know where to find Alvaro, Matthew, and myself to learn more. Thank y'all so much. We'll see you next time.
Thank you very much.
All. Bye.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.